Volcanoes are awesome. They're also dangerous, and we can't predict when they will erupt. But if we want to understand them, we need to start with how they work. So let's talk about magma chambers, tectonic plates, and eruption types. This is crash course geography. Volcanoes happen when rock in the Earth's mantle melts, creating magma that makes its way to the surface. Like at the Peru-Chile Trench, where the Nazca Plate is sliding under the South American Plate. Where the plates meet, deep in the mantle, the intense heat and pressure hundreds of kilometers below the surface can melt rock. For example, in the Eastern Pacific, the Nazca Plate has been sliding under the South American Plate for 30 million years. Yet there are no volcanoes in northern Chile. That's because even though the Nazca Plate is mostly made of oceanic crust, the South American Plate isn't. Oceanic crust subducts more easily under continental crust because the denser oceanic crust pulls the lighter continental crust down with it. These are areas where magma seems to come from deep in the mantle without any obvious plate boundary nearby. Where they are located determines what kind of volcano might form. And they can emit runny or thick lava, and they can blow their tops off or just ooze. Lava domes grow when lava is thick and sticky and doesn't flow very far from the vent. Instead, it piles up around the vent like toothpaste from a tube. Since lava domes don't have much gas in them, their eruptions aren't very explosive. These are stratovolcanoes that have had exceptionally large and powerful explosive eruptions. Their eruptions can reshape landscapes in a single day or create new landforms over millennia. You want to help keep Crash Course free for everyone forever? You can join our community on a crowdfunding platform. Plus, their presence affects where people settle and how they use land. And the way we study volcanoes helps us better understand Earth's inner workings. In fact, understanding volcanoes gives us insight into our planet's evolution, and it helps us prepare for the challenges they pose. After all, humans live in close proximity to volcanoes. More than 500 million people live within the zone of 100 kilometers of an active volcano. And because volcanoes are unpredictable, studying them helps keep us safe. The term supervolcano refers only to the potential for large eruptions, not necessarily the size of the volcano itself. But their slopes are usually steep and unstable, so they often collapse, causing pyroclastic flows. These are extremely hot, fast-moving mixtures of gas, ash, and rock that race down the volcano's slopes. There are even composite volcanoes that combine characteristics of different types. The steepest volcanoes with loose, cindery material on their slopes are called cinder cones. Cinder cone eruptions are small and short-lived. They create cones less than 300 meters tall made of tephra, which is broken rock fragments ejected during the eruption. Cinder cones look like piles of rubble, and they tend to have a bowl-shaped crater at the top. Most of them don't have flowing lava, but instead have explosive eruptions that throw tephra for hundreds of meters. We know that hot spots aren't actually spots because no hot spot has ever been found to have magma beneath it while it is active. Instead, they're linear magma-producing zones. We call them hot spots because they have a high concentration of volcanoes. Their shape comes from alternating layers of runny and sticky lava and tephra deposited during many eruptions over thousands or even millions of years. Stratovolcanoes have both runny and thick lava flows and explosive and effusive eruptions. You might think of Mount Fuji in Japan or Mount Kilimanjaro in Tanzania as classic examples. And the rocks in those volcanoes tell us that the magma comes from deep in the mantle. They have broad, gently sloping sides made of runny lava. They form at hot spots or divergent plate boundaries where large amounts of lava flow out over vast areas. Unlike stratovolcanoes, shield volcanoes have few explosive eruptions. Instead, their eruptions are non-violent outpourings of lava. Mauna Loa in Hawaii is the world's largest shield volcano, and it illustrates this type pretty well. For example, the Hawaiian island chain is a hot spot that formed over a mantle plume and a quelling of abnormally hot rock from deep in the mantle. Scientists think mantle plumes originate from the core mantle boundary and that they may be the reason why some volcanoes form outside of plate boundaries. Also, the angle at which the plate is subducting matters. When the angle is shallow, the plate doesn't melt much, but as the angle steepens, the temperatures and pressures increase, melting more of the plate. This creates magma that's buoyant, meaning less dense than the surrounding solid rock, so it rises toward Earth's surface, like at mid-ocean ridges where new seafloor is created. Magma can bubble up from deep in the mantle and solidify as new seafloor. These happen when large amounts of magma are released in a short amount of time. One of the largest examples is the Deccan Traps in India. Geologists think their formation was related to the extinction of the dinosaurs. In fact, scientists know that's happening because as new seafloor spreads out from the ridge, it's hotter and more magnetic. If it reaches the surface, it erupts as a volcano. In fact, many volcanoes form this way, including some of the largest ones on Earth. Magma is like soup made of molten rock, but it's full of dissolved gases like water vapor and carbon dioxide. As it cools, some of these gases escape and others stay dissolved in the magma. The stuff that escapes becomes part of the volcanic ash and gases emitted during an eruption. The stuff that stays dissolved creates pockets of pressure within the magma. And the more gas that gets trapped, the more pressure builds up. Eventually, the pressure from the gas is greater than the strength of the surrounding rock, so the rock breaks and the pressure is released in an eruption. But where does this magma come from? To answer that, let's talk about tectonic plates. These are huge slabs of rock that make up the Earth's crust and most of the mantle. They move around on top of the asthenosphere, which is a hotter, softer layer of the mantle. It formed because the African plate is moving toward the Eurasian plate and the Adriatic microplate is sinking down into the mantle, or the Mariana Islands in the western Pacific Ocean. These islands formed when the Philippine Sea Plate began subducting under the Pacific Plate about 40 million years ago. The Mariana Islands are actually a volcanic island arc, a chain of volcanic mountains that formed in a row along the subduction zone. Other well-known examples of volcanic island arcs include Japan and Indonesia's Lesser Sunda Islands. Now there are different kinds of plate boundaries. And depending on what kind of boundary a magma chamber finds itself near, the kind of volcano that forms will be different. Let us say there is a subduction zone where two plates are colliding and one is sinking down into the mantle. Let's take Mount Vesuvius, the volcano that destroyed the Roman city of Pompeii in 79 AD. It's important to note that not all subduction zones have volcanoes. Sometimes magma chambers don't form at subduction zones, but at divergent plate boundaries where plates are moving away from each other. In addition, at divergent plate boundaries on land, magma can rise up and form vast outpourings of lava called flood basalts. And finally, there are hot spots. So those are the three main ways magma chambers get started: subduction zones, divergent plate boundaries, and hot spots. Broadly speaking, volcanoes are categorized by their shape, size, and eruption style. Volcanoes can be steep or gently sloping. They can be large with wide bases or small. The smallest type of volcano is a lava dome. These are mounds of viscous lava that pile up around a vent. Stratovolcanoes or stratocones are large, steep-sided volcanoes. Shield volcanoes are the largest type and they look like, well, shields. But there's another type of volcano that doesn't fit into these categories: supervolcanoes. Now remember that volcanoes are not just landforms, they're also agents of mass wasting and geologic change. Thanks for watching this episode of Crash Course Geography, which was filmed at a studio and made in partnership with a digital studio and nature.